Hi friends, welcome back to the channel. In this channel, we try to solve the previous year's physics question papers of NEET undergrad exam, which is held in India. This is also helpful for those students who are appearing for the joint entrance examination mains, which is JEE mains for engineering stream, as these are also NCERT related questions. We have made all attempts to solve this in an easy manner so that you can easily grasp the concepts and you'll be able to follow it going forward. We are also trying to solve all the different varieties of questions which appeared in the earlier question papers so that you don't miss on any concept. We hope that you are all able to follow the solution easily. Just in case you have any doubts, then please feel free to add in the comment section and we will revert to you at the earliest possible. So without much ado, we'll start solving the problems. So in the earlier instance, we had solved from questions 1 to 6. So now we will move to question 7. So in the earlier question we had, in the question 6, we had a scenario that again we had rocket which is firing on towards the top, right? So here also we have a 1000 kg rocket which is set for vertical firing. So how will the rocket look like? So imagine that this is a rocket, right? Okay, and this is surface of Earth. Now this is supposed to be moving up. This is supposed to be moving up. Now, just in case we do not know how is a rocket fired, so there are a lot of gases which are fired at the bottom of the rocket, because of which there is huge propulsion which takes place because of the firing of the gases. There's a lot of propulsion which takes place, and it pushes the rockets forward, which is upwards. Okay, that is why, and you know that there is a force of gravity acting on the rocket, right? So the huge propulsion force required by the burning gases to move the rocket towards space. Okay, so having said that, let's get into this problem now. So we saw earlier also the same formula. So we have a force moving up which is V dm dt, right? But in the earlier problem, if you recall, that there is no acceleration we are talking of, right? So we were assuming in the earlier cases that the upward force is the same as the downward force, right? As if the rocket is going to move at a constant velocity because of no additional force, right? That was the understanding in the previous question. It's question 6. In question 7, it is given that there is an additional acceleration required, which is 30 meters per second square, if you look at it, right? Okay, so we need to give it the additional 30 meters per second square. So now let's look at this, right? The force, which is the upward force, and this is a gravitational force with downward force, correct? So the upward force, which is V dm dt, right? Okay, minus the downward force. The downward force is mg, right? And this minus this should result in the rocket moving up at an acceleration of a, which is the force is ma, at which it will move up, right? This is ma. Okay, so what does it mean then? V dm dt is equal to mg plus ma is equal to m g plus a. Okay, so now we need to find what is the amount of gas which is ejected to supply the required thrust. So that is the ask in this case. Okay, it means the dm dt, dm by dt is equal to m g plus a divided by v. Okay, the mass is 1000, the gravity is 10, plus the additional acceleration is 30 divided by v, which is 400 meters per second. Okay, so this goes away. This is equal to 10 divided by 4 into 40. Okay, so this is equal to 100 kg per second. So this is the answer for this case. It means 100 kgs of gas per second has to be ejected per second. Next one, a ball of mass 250 grams is dropped from a height of 20 meters. Right? So imagine that the ball is getting dropped. Okay, 20 meters height. Okay, the weight is 0.25 kilograms. Okay, so this is what is given here. Now, if it is hitting the ground at this place, the velocity is v, right? So what will be the velocity at which it will touch the ground? V square is equal to u square plus 2as. If you followed my earlier solutions, v square is 2 square plus 2as. So it is being dropped from the top, right? So basically u is equal to 0. The initial velocity is 0. It means v square is equal to 2gh, where a is g and s is the height. Okay. So now in this case v square is equal to 2 into g is 10 and height is 20. This is 400. It means v square is equal to 400 and v is equal to 20. So v is equal to plus 20 because minus 20 is not possible. So v is plus 20 here. Okay. So what is the impulse? Is equal to mv minus mv. Okay, change in momentum. This is equal to 2mv is equal to 2 mass is going to be, which is 0.25, and the velocity is going to be, which is 20. So the answer is 10. Okay, this is the answer, like 10 kg meters per second. Okay, let's go to the next problem now. The force acting on a body of mass n is shown by the graph below. So this is the force here. If you look at this, this is the force given here. So this is the force, direction of force, and this is time, right? What is the change in momentum of the particle over the time interval? Okay. So now we know that what is the delta change in momentum in momentum is equal to delta v. Okay. So now this is also equal to m k into delta t. Okay. So now in this case, we will find ma into delta t, right? This is equal to force into delta t. Okay. So this is given the force, and this is the t. Okay. So what will be the change in momentum, which is the sum of all these areas, right? This area plus this area plus this area. Okay, so how much is this area? So the triangle area half into base is 2, height is 8. Okay. This is on the negative side, the second part is on the negative side, so it will be minus 2 into 4. Okay, why 2? Because 4 minus 2 is 2. And what is the height? 0 to 4, right? This is 0 to minus 4 is 4. Okay. Now the next one is a rectangle, right? So rectangle, what is the area of this? The total is 4, horizontally it is 4, and vertically also it is 4. So 4 4 is 16, right? Plus, sorry, plus 4 into 4. Okay. Now this is equal to 8 minus 8 plus 16 plus 16 Newton second. Okay, the answer is 16. Okay. Let's go to the next problem. A cricketer catches a ball of mass 2. So imagine that a ball is coming this way and the cricketer is catching the ball, right? So he'll basically put his hand up. Right. So the ball comes to him, ball comes to his hand and is basically getting stopped, right? Imagine a ball is being thrown from here. The batsman is hitting the ball, right? The ball comes here in the hand and the ball is stopped here, right? So we have a person who is hitting the ball. Okay, so the mass of a ball, is equal to 100 grams is equal to 0.1 kg. Okay, what is the velocity? Is equal to 25 meters per second. Okay, so now when the ball is being caught, so basically at this point the velocity is 25, right? Before, so imagine that this is the hand, this is the point at which the hand is touching the ball, right? The ball is coming like this and is basically stopped here and gets trapped here at the hand. Okay, so the change in velocity, initial velocity is this, the final velocity of which is 0 because the ball is getting stopped. So the ball is getting stopped by the cricketer, right? So the velocity changes to 0 after the ball is caught. Okay. So Vv is equal to 0. So what is the change in velocity? Change in velocity is equal to 25 minus 0 is equal to 25. So this I can say this is equal to delta V. Okay. So now what do we need to find here? What is the force experience, right? Force is equal to mass into acceleration. Okay. Mass is given to be 0.1 and acceleration is the velocity divided by time. So change in velocity, which is 25. And what is the time taken by the cricketer to stop the ball? It is actually 0.1 second. So this is equal to 25 Newton. Okay. The answer is 25 Newton, which is the second option, which is P. Well, let's go to the next one now. A satellite in a force-free space sweeps stationary interplanetary dust at a rate of dm by dt is equal to alpha t. What is the acceleration of the satellite? Okay, so we all know V, force, is equal to d dt of m v. Okay, which is equal to m vv by dt plus v dm by dt. Okay. Now it is given that dm by dt is equal to alpha v. Okay. So dm by dt alpha v. So this is equal to m into dv by dt plus v into alpha v. This is equal to m dv by dt plus alpha b square. Okay, alpha b square. So we know that m dv by dt plus this is equal to 0, right? So it means m dv by dt plus alpha b square is equal to 0. Okay? It means dv by dt is equal to alpha b square by m. Now, what is dv by dt? It is change in velocity with respect to time, and this is nothing but the acceleration, right? Acceleration. So this is equal to alpha b square by m in negative. So it's equal to minus alpha b square by m. So this is the answer. The second option is option B. Okay. Let's go to the next one now. Let's go to the next question. A balloon mass m is actually moving down. Right? So imagine a balloon is there, a big balloon which is there, which is moving down, right? Which is moving down towards the earth. Okay. So when it is moving down, so obviously there is some force which is taking it up, right? There is some force which is taking it up, and obviously there is an acceleration which is happening downwards also. Okay. So it means since it is going down, it means the bottom force is more than the upward force, right? So I can say that mg minus f is equal to ma. Why? Because obviously there is a gravitational force which is acting on this, and this is equal to mg. Mg minus force, because this force is taking it in the upward direction. This minus this is equal to this. This is the force. So it means that force is equal to mg minus ma, m of g minus a. Okay. Now, if it has to, it is saying that, so what is saying here, how much mass needs to be taken out from it so that it starts moving with an acceleration of e. So if some mass has to be taken out of this, okay, if some mass has to be taken out of this, then what happens here is that then it will move upwards, right? So it means F, so then there will be a net force will be on the upper side, okay? So force minus m dot g is equal to m dot a. What is m dot? M dot is the net weight after taking out some air from this, okay? So it means F is equal to m dot g plus a. Okay. So there is one important thing is that given that it is moving down with an acceleration a, right, and also going up with an acceleration a, so it means that in both the cases the force is the same. Just that in the first case it's going down with that force, but in the second case it is going up with that force. Okay, right? So it means this force is obviously equal to this force, right? So we can say that mg minus ma is equal to m dash g plus m dash a. This is one important thing to want to know, right? So the question is, how much mass has to be taken out from here, right? What is the net mass to be taken out from here? Net mass to be removed is equal to m minus m dash, right? So m minus m dash is equal to m minus, so what is m dash here in that case? So mg minus a, so m dash G plus A means M dash is equal to M G minus A upon plus this is what we have found till now. So if I find M minus M dash here, so net force to remove M minus M dash. What is M dash here? M G minus A upon G plus A. So if we solve this, this will become Mg plus Ma minus Mg plus Ma on G plus A. Mg and G goes away. So we have to 2 Ma upon G plus A. It means this much air has to be taken out from the ball or from the balloon so that it can move upward. Okay, so the answer is B. Okay, so friends, that's about it for this particular topic. So we have solved 12 questions in all on this topic. If you have any doubt on this, then please do not hesitate to drop us a comment in the comment section, and we will try to resolve the same at the earliest possible. Okay, team, thanks for being with us. I hope you subscribe to our channel so that we get such interesting, educative videos going forward. Okay, thanks, team. Bye.